Hello everyone and welcome to our AP Physics 2 production. My name is Morcos and I will guide you through our project concerning all things fluid. Now this video features several experiments concerning various phenomena and physical properties of fluids and explanations of each. Let's get started. Here we have a 500 gram weight. We will place it on a scale as shown and we will measure its weight. Naturally, it will show 500 grams. Now, however, we will immerse this object in a special fluid we all have come to know and love, water, and observe the difference in the scale's reading. So here's the weight. We put it on the scale. It reads 500 grams. And then once we submerge it in water, we find out that the reading has decreased to about 400 grams. As you can see in a closer picture here. Now, why do you think this is? How can this be? If you said buoyant force, you are correct. Buoyant force is the upward force on a submerged object that is equal to the weight of the fluid that is displaced by the object. Thus, the force acting upwards counters the downward gravitational force and causes a scale to read a smaller measurement for the weight. Isn't physics amazing? For our next experiment, we have a simple water bottle with a brand removed for a clearer view. Notice the top is open and without a cap. Also, two holes were punctured, one near the top and the other further down. What do you think will happen? Will water leave both holes? Will it leave with the same speed? Now let's find out. So here it seems that the water coming out of the bottom hole is going at a much faster speed than the water coming from the top hole. This makes sense because the water at the bottom hole has much greater force pushing onto it. The whole weight of the water above it is pushing onto the water near the bottom hole as opposed to the one near the top, causing the water to leave with a greater velocity. Now here we added a little twist to the system. And if you can't spot the difference, my finger is pointing at it. We added a cap to the water bottle. Now, what do you think will happen differently because the cap is there? Let's see. It seems that the water is only coming out of the bottom hole. Now, this has to do with pressure. The pressure inside the container is initially stable. Yet when I release my fingers and the water pours out of the bottom hole, a pressure difference is created, and to make up for this pressure difference, air tries to get into the water bottle. Since the cap is no longer removed from the water bottle, the air has to enter through the only other hole, which is the top hole, and prevents any water from dissipating out. Now, for our next experiment, we will deal with a phenomenon that has amazed scientists since the beginning of time. The characteristic, the physical property of density. To the left, we have a simple wooden block, and to the right, we have the weight, which may seem familiar. Yes, it's the same 500 gram weight. And we will immerse these two objects in two fairly identical beakers of water and observe what happens. As you may expect, the wooden block floats while the metal weight, sinks to the bottom. Now this has to do with the property of density. Density, or often called volumetric mass density, is the mass per unit volume measurement of a substance. Now, why is density so important? Well, things float when they are less dense than the fluid in which they are sitting. Since water has a density of 1, any object that has a greater density than that will sink, and any object with a density less than 1, like the wooden block, will float. This property of density is a truly fundamental concept in physics. Here we have one of my most favorite experiments in the whole group. This is just a regular paperclip. Nothing magical, nothing special about it. In fact, it is more dense than water with a density of greater than 1, and it will sink when placed in water. However, watch this. When placed ever so carefully on top of the water, the paperclip floats. Now, how can this be? It is no magic, it is physics. In fact, when you touch it a little bit, it falls, sinks to the ground like it should. Now, how can this be? It is a phenomenal property of cohesion. Since water is a polar molecule, meaning one side is positive and one side is slightly negative, the intermolecular forces between water molecules create strong bonds, and at the very top of, say, a surface, these molecules are compressed together and these bonds are ever so strong. And sometimes when the strength of the bonds and the cohesive forces between the molecules are greater than the force of an object pushing down, even though the object may have a greater density than water, the force can keep it afloat. Now, this cohesion is between water molecules. There's also adhesion, which is the property of water and other fluids in their interaction and bonding or attachment to other surfaces. These properties are phenomenal, and as you can see, they can almost seem magical. For this next experiment, we have a simple piece of paper, also no magic here. But when I take this piece of paper, hold it horizontally so that none of it is over my mouth, and blow just straight over the top of it, we see that the paper floats upwards. Now, how can this be? Well, when I blow above the paper, the air is rapidly moving. Rapidly moving air causes a decrease in air pressure. This decrease in air pressure creates a gradient. The pressure gradient goes from high pressure to lower pressure. And so the higher pressure, which is all around, including under the paper, tries to get to where there is lower pressure or above the paper, and in doing so, the air pushes the paper upwards and it floats upwards, even though I am not blowing at the paper or even under the paper at all. For our final experiment today, we have a pressurized container. In other terms, a water bottle that is twisted so that the pressure inside is much higher than atmospheric pressure. Then, at very high pressure, we released the cap. Boom! So what happened here? Well, the pressure inside caused the cap to expel at a very high velocity since it created so much force. Another point I would like to point out is what happens after. As you can see, there is water vapor, visible water vapor coming out of the water bottle. Now, how can this be? Well, inside the water bottle, as we just said, there was a great deal of pressure, higher than atmospheric pressure. As we know, fluids like air, when under high amounts of pressure, become more stable, either as a liquid or as a solid. So in the water bottle, the water vapor in the air condensed to liquid form, and when the cap was released, the pressure decreased dramatically, causing the liquid water to return to its original pressure and thus vapor form, creating that amazing image you see before you. Now, I want to take this time to thank you all for watching. Stay tuned to our next edition of Physics.